Here we go. 3 gears have 107 teeth. Okay, so it starts talking about the gear. This gear has more teeth than that gear. Okay, I'm already getting a headache. So what I'm going to do is this. I'm going to say okay, forget the let statement. Number of teeth on first gear. Okay, it's not pasting. So if we let the number of teeth on the first gear be x, how many teeth will be on the second gear in terms of x? X plus something, yeah. X plus 13, yes. Thank you. And then we have the third gear. So the third gear has 15 more than the second. It's close. It's going to be 13 and 15. Because it's 13 to get to the second, and then 15 extra to get to the third. Cool. Thanks, Shazad. So yeah, toss those into an equation. I think we're good. So I'm just going to create an equation here. And there's 107 teeth in total. That's pretty much it. If you can solve this, you're looking good. This is the type of equation. This is the level of difficulty for like the harder questions on your quiz that you would see. I think your quiz is 2 questions involve some algebra, and this is the worst algebra you'll see for one of the 2 questions. So just so you understand, it's not like some really nasty algebra. So if you're following along with the algebra today, you're going to be just fine for the quiz. So when I look through the first set of terms on the left side, I see there are 3 x's. Yes, x is 22. I will catch up to you. Now, if we take 13 and 13 and 15, we get 41. And then you can move the 41 over. So 3x equals, I'm going to do baby steps here because I like baby steps. So that's 66. And you can divide by 3 to get 22. Thank you, Shazad. Awesome. So that's great. That's fantastic. But we have not answered the question. What is the question asking for? What does the question want?
20 teeth just each gear have.
Yeah, every gear. So we got to go through each of them, okay? So the first one, yeah, 22, sure. What's the next one? What's 22 plus 13?
35.
And the last one, oops, is, I'll just put 50. I should have put 50 there. I see a 41. I'm not sure what the 41 is. Anyway, so the answer is in red. Well, it's going to eventually be in red once I highlight it. There you go. Because you're writing your quizzes and potentially your tests on the platform MyLab, you don't have to worry about therefore this and let that or whatever. The questions are going to be fairly short, and the final answer is all you need to present. So for questions that are more difficult, there is a level of risk involved, but I promise you that I will balance out your evaluations with many short questions and a few longer ones, so that it's not all or nothing for the longer ones. And I'll choose longer questions that have part marks as much as possible. So that's a nice little question. It's a linear equation because notice we have x's only. We don't have x squared. We don't have x cubed. Nothing weird. So the next questions we'll do, the next two questions will also be a word problem involving linear equations. So what I'll do is I'll expand the sides here so that you can see it in a nice big font. So if you're falling behind on a question, you can see it in the margin. So let's go to 41. I'll give you 30 seconds to read, and then we'll start taking it up. So I'm not getting a head start on you. I'm just going to write down my let statements. So here's the thing. You're told that if you build a bridge with 18-meter girders, you'll need this many, but not exactly the number. All you're told is relatively how many girders you need relative to the 15-meter option. So if you use shorter girders, you'll need more of them to span the length of the bridge. The question is, how long is the bridge, or what's the span of the bridge? Well, this question gave a few people a headache in the past couple of lessons, but you need to let something be x, or whatever variable you feel like. So you know what? I'm not going to read the question too carefully. I'm going to let this guy be x. The reason I don't want to go too careful sometimes is because it's going to give you a headache. Like, if you're like, which one should be x? Honestly, it doesn't matter. So don't like worry too much. If the choice of x makes it harder for you to solve, make the other one x. So there are x 18-meter girders. It says here that 4 fewer 18-meter girders required than 15. So you need more 15-meter girders. How many more 15-meter girders do you need relative to x? Thank you. Thank you, Brian. Thank you, Ahad. So yeah, x plus 4. There you go. So now if we talk about length, the length of the bridge in terms of those girders is going to therefore be 18x. Because if you have 18 meters per girder and there are x of them, then it's 18x. What would be the length of the bridge in terms of 15-meter girders? What expression?
15x plus 4.
I like that you're telling me over the mic, but I don't know who you are, and I feel terrible. Who was talking right now?
Anthony.
Anthony. Okay, just making sure. Because I got like a little blurb at the bottom, and people's names are popping up as I'm writing. So yeah, thank you, Anthony. So 15x plus 4. There you go. So what you know is the following. In contrast to the previous question, you're not going to add these things up. These things don't add up to something. Actually, they do. They add up to 2 bridges. But we don't want 2 bridges. We want 1 bridge. So what we're going to do is we're going to say, look, if you use the first option, the bridge is this long. If you use the other option, the bridge is that long. And whichever option you choose, those options have to equal the same number. So that's your thing. Option A should equal option B. And then you can just solve that. So let's expand that out. So you bring the 15 in the brackets. 15 times 4 is 60. And then you can move the x over. You should, I think you get, oops, not 20, 60. Thank you. That is correct. 20. Sometimes these equations don't line up on my screen, but hey, it's okay. You can do a better by hand for that. So then we can go back to the question and say, how long is the span? So the answer to the question is this thing here in red. So the answer will be 18 by 20, which is how long? Yep. And what are the units? Thank you. If you chose to use the other option, it should be the same answer. So let's confirm that. So that'll be 15 times 24, because it's x plus 4. And last time I checked, 15 times 4 is also 360. Okay. Not too bad. I think we've taken a nice dent out of the first two questions. So I'll scroll aside here. And so yeah, on the actual application, I do think that the units, for the most part, are not needed because it's beside the box. So like you'll get something like this, Devin, on MyLab. This is what you'll get, okay? I'm just making up something over on the side here. My answer is blank meters. That's how you'll see it, okay? Something like that. And you just have to put numbers. Or a formula. Some questions make you, they're like, give me the formula or rearrange the formula. How we did last week, we rearranged formulas a little bit. So yeah, but I don't think you need to put units unless explicitly told. It's very clear. So don't worry too much about that. I am going to talk a little bit about MyLab before you write the quiz, because MyLab is very picky on how you enter in symbols. So I'll talk about that later. Maybe Kiara, come out and back into the session. Maybe someone might have had that issue yesterday, I think. Okay. So let's go to 42. Just give 42 a read there, and we'll start taking it up shortly. Yes, Saad, you will be doing the quiz on MyLab. You will just be typing a final answer there, and all your rough work you can write on paper. Sounds good? You're welcome. What's the verdict there, Kiara? Does it sound better now or no? Oh my goodness. Okay. The worst case is that the session will be recorded, and my version won't have fuzzy sounds or anything on it. Dogan, I think that because I am using a different format this semester, it would be a combination of the two. The quiz still would be online, but probably I would assign it off class hours. I am doing the quiz on class hours just to be here to support you. The tests typically in the past have been on paper, but I'm going to be switching to the online version of the test this semester. Because I think that it's going to be more protective of the integrity of the testing process. So that's my clear and honest answer. You're welcome. Okay, so the question here, we have a delivery firm that has different types of trucks. It has trucks that operate on 8-hour routes. Maybe it's because that's how much gas they can burn in that time. And other trucks, it's 6-hour routes. Or maybe it's because they have shift workers and they have certain shifts that they have to follow. In any case, This question, you might say, what does it have to do with construction management? Well, I mean, you do deal with deliveries in construction, and if you replace delivery trucks with, I don't know, you can replace it with anything that operates on an hourly basis. You can see that it does have a similar structure to a customs type scenario. So like it could be delivering supplies or whatever. So it is a very applicable question. So the number of trucks on the 8-hour routes, we don't know what that is, and we don't know what this is. Now some of you might do this, X and Y. But yes, thank you, Saad. But I don't like using more than variables than I need. I always want to write the fewest number of variables to get away with, like, I don't know, just less variables. So I like to immediately write the second one in terms of X. So it says the second fleet with 5 more trucks than the first. Yes, it's X plus 5. So we got to put an X plus 5 there. Thank you, Peter. Okay, so I think we're good. I think we're good now. We can just build up a formula. So we have here the time. The time would be 8x because there's 8 hours per truck and there's x of them. And the time for the other ones would be 6x plus 5. We each put them together, and then we're laughing. That's 198. So that's 8x plus 6x plus 30 equals 198. I don't know why this font is different, but that's okay. As long as you can read it. So what'd you get for x? Yes, 12 is good. How are you doing with the pace, people? How are you guys doing with the pace? Is the pace okay?
Pace is good.
Just trying to keep it, just looking for different names. That's all. Making sure that we have a variety of responses. Okay. There's like I can do like polls and things like that, but if I do polls, every time I do a poll, I could do an example instead of a poll, and I think you get more from another example. So anyway, thank you for your patience on that. So yeah, x is 12. So we have to answer the question now. So the question is how many trucks? So we can do it at the bottom here. So there are 8-hour trucks and 6-hour trucks. For the 8-hour trucks, there are 12. I'll write it in English. And 17. There you go. Let's write it in English. You know what? Let's make it look a little bit human. Okay. So anyway, that's enough of the word problems. Fancy, fancy. So we're going to move on to some calculations involving percentages. So I'm going to just dive in here and talk about a very important pattern, okay? What is, I'm not yelling at you with the capitals here. That's too much yelling. I don't like how I'm saying that. There, that's what I'm trying to say. Calculators are allowed in this course. You can use a calculator, absolutely. Why? No, I'm not drinking tea today, Brian. I'm drinking my decaf special. Why, do I sound more energized? Victor, your answer is good, but you have to round it to the nearest 3 significant digits, okay? But the answer, numerically, your calculation is correct. I want you guys to focus on this template here. Yes, 377 is the best answer. So we have blank is blank percent of blank. Every single question with percentages looks like this. And what does the word of mean in math? What operation is that? Is it add, subtract, multiply, or divide? What does of mean in math? What operation? Yeah, it's multiply. Good. So is equals, and of is multiplies. So this I want you to kind of take to heart because that's the key to doing all of these questions. And I'll use this pattern to do the rest, to do 3 questions with you. There's going to be 3 questions because there's 3 different types of question marks. So let's see this question, how it fits in. So we have what is, and there's your multiply, 52.4% of, there's your multiply, and then 720. So you don't have to call the question mark X or anything. You can clearly see that the answer is just multiplying those 2 numbers. But I like writing the question mark so that you understand that you can treat it like an algebra question if you prefer. How do you convert a percent to a decimal? What do you do? Yes. Ooh. I think it's divide, right? Yeah, divide, right? It's going to get smaller. All good, Jovan. So, there you go. Whoops. I'm typing in the chat instead of on my screen. There we go. Hey, you can type it on your calculator. That's not a big deal. I'll just go sideways here. Actually, no, I'll go underneath. So what do you get? $377. Now you might have said, well, I didn't get 377. I got I don't know why the symbol's not working. It's weird. There we go. So it's $377 because you're rounding the answer to 3 significant digits. So a couple of people quoted a decimal value at the end. I got rid of it just because the question said 3 significant digits. Let's play this game again a couple more times with 2 other variations to percent questions. So again, if you missed the answer, I have it on the side here. You might have to zoom in a little bit for that. But let's move on and just kind of do the same thing 2 more times. So notice that this question, the unknown quantity is placed elsewhere in this relationship or in this pattern. So it says 18 kilograms. So if you just read it, it's 18 kilograms is equals question mark for percent. I'll put that in brackets. Of is multiply. So if you just take it literally, you have the exact same thing as last time. You have an expression that is with 1 quantity that's missing. You can call that X if you want, but you don't have to. I think this question is actually the most natural question, or the one that as a calculation you probably did the most in school. Like if let's say that you got 18 out of 21 on a test, that's something I'm pretty sure that you did on your calculator to see what percent you got. So that's this type of question. Yeah, I think that's right. That sounds right. So let's write that down. So I'm just going to say here, answer 18 out of 21, or approximately 5.7%. Okay. You can repeat this again with the next question. And in this case, it's just the last permutation or the last version of this question. Remember, just read the sentence. This is means equals and of means multiply. So 17.5, I won't put the units this time. 17.5 is 19.5% of something. So we know the answer. For these questions, I refuse to create a variable. It's not needed. It's too much overkill, you know? So the answer here would be divide. So 16.5 divided by 19.5%. And you can turn that into a decimal. So I think, Saad, for the quizzes, for the evaluation, Saad, just do whatever the question says, okay? For the booklets that I've written, most questions are 3 significant digits. But yeah, you're not going to have to play any games like you did in science class, possibly, where you had to round based on the limiting accuracy of the numbers. No, none of those games. Just whatever the question says, do it. And also, not for this week, because this week there's no weird decimals in your test, in your quiz. But for future ones where there might be decimals or weird stuff like that, I'm going to allow for a tolerance in your answer. So if you answer, like, let's say the answer is here, that's right, Shazad, it's 89.7. If you have 89.6 or 89.8, I'll tune it so that it allows for those things. So I'm going to do a couple steps here just because you should practice your conversion. And then, of course, this is 89.7 as correctly stated. What are the units there, Shazad? Kilometers. Yeah, kilometers. That's good. Okay. All right. So I mentioned that we're going to skip some questions because they are redundant. So I did 3 questions with you that followed the 3 different versions of this template in the blue box here. So these questions, 46, 47, 48, is the same kind of thing, okay? Excuse me. So during the break, I'll post the final answer for these on the screen. So don't worry about doing these yet. You can try them during the break or just on your own for an exercise. So we're going to move on to a different type of percent question. So just take a quick read of question 49. Okay, so this type of question is called a percent increase question. Notice that this question, the word of, it did not appear at all in this question. In the previous ones it did. I haven't gone that far, but let me take a look, Victor. Yeah, 919 is good. You can get rid of the decimal because of the nearest dollar. No, it's not redundant, Ravina. I will definitely will help you get through that, okay? So not a problem at all. So the main thing is that you need to get MyLab, and then once you have MyLab installed, once you have access to MyLab, then it's all good. But I've given a 2-hour window when the quiz starts for you to have lots of time to deal with all that technical stuff, and I'll be here in the chat to help you. Okay, so this question is not a question involving of, so it's not one of those weird pattern ones that we just did. It's a percent increase question. So when you have a percent increase question, one way to do it that I like to do it is multiply by the following: 100% plus whatever the increase is. Whatever the increase is. In this case, the increase is 27%, so that's 127% or 1.27. So You just multiply by 1.27, okay? So that's how you do the increase question. So let's do that here. So 724 times 1.27, and to the nearest dollar, because the look at the answer, it's wanted into the nearest dollar. So we already had the answer mentioned. It was $919. So that's good work. So you can do this question again right here. So figure out goes here and here, etc. So I'm just going to leave that as a template. You got a minute to figure that out, okay? 1 minute's plenty of time. Yeah, 1305 is correct. Make sure you put the units, but it's correct. I'm not picking on you, Shazad, about the units. The next chapter we do, it's all about unit conversions and formulas. Okay, I'm picking on you a little bit. Fine. Keeping me honest, Victor. Keeping me honest. Okay. You know, I am a rocket scientist, eh? G gets it. I know he does. She. Oh my God. I need to see a face there. I got a bubble. Now, do I pronounce it G or J or Jet? Please tell me how to say it correct. Because Victor's gonna pick on me some more. All right, forget it. I give up. Melody. That's an awesome name. You know, I tutored a girl named Melody like a long time ago, like maybe 10 years ago. Johnny Rockets, I like that. You got to get this story here. Melody, I tutored a girl named Melody. She was in high school. She was 16 years old, okay? She ended up being an emergency room doctor. So you got a good stock there. Melody's a very smart name. I bow to the Melodies. Okay, so there we go. Johnny Rockets. What Rockets? I don't know what you guys are talking about. Elton J. Okay, I'm over it now. Let's move on. Yeah, I am a rocket scientist. Of course. Sometimes I'm a space cadet, but most often I'm a rocket scientist anyway. I'll stop talking and do math because I've already embarrassed myself enough times. So I'm just going to stop talking. How many kilometers, people? How many kilometers? Help me out here. I'm failing miserably. What are the whoops? Yeah, 1305. Thank you. I don't like making mistakes with things, and I feel terrible if I say something that is incorrect. So if I say something that's incorrect, I apologize, but I'm not trying to offend anybody. So hopefully everybody's good. I'm learning to use this gear as much as you guys are too. So anyway, those questions are called percent increases. Why don't we do a question involving a decrease this time? So that's where you see this word here. This is the word that messes up everybody. Off. It's different than the word of. Okay? So I want you to think about how to solve this. I'm going to return to the lesson in less than a minute. I just got to do something quickly because okay. I think the answer, I know the answer is 1500. But let's talk about how you do it. Let's talk about how you do it, okay? So the word off means that you're taking off something. You're reducing something. So it's a discount. So I'm sure you've heard of the word discount in your life, because it's the same thing here. You're discounting or reducing by 25%. So you're still going to multiply by something. I'm going to show you one way, and then I'll discuss another way. So when you have a discount, you take away from 100. So you get 75 or 0.75. And then the answer becomes what's 2,000 times 0.75? $1,500. Okay? There's another way to answer this question of several other ways. What you can do is say, look, I'll take 25% of 2,000, which is $500, and then I'll take that away. So what you do is you figure out how much you're saving, and you get rid of it. But that's it's 2 steps, and so is this. This is also 2 steps because I need a step to create the multiplier right here, and then I have to apply the multiplication here. So either way you slice it, it's 2 steps. So anyway, there we go. Let's talk about question 52. It's the same thing, isn't it? Okay, so I'm going to just write the answer with 1 step and see if you can sort it out. I think it is 38, but don't quote me. Yeah, it's 1138. Thank you. So I'm going to do 1750 times 100 minus 35%, or 0.65. Thank you. And it's 1138. That's great work. You are all doing very well here. That's very good work. Okay, so I will keep on going here with the good stuff, but we need to move on to another topic. So we're going to talk about ratios for a little bit. I know that we're approaching our potential first break, but I do need to cover a few ratio questions with you, just to make sure that we are on pace for the lesson. Okay, so just read question 53, and we'll take it up in 1 minute. Try to calculate it yourself, of course. Okay, so hopefully I gave you a minute. I wasn't literally counting the time. It says here the efficiency of a power amplifier is the ratio of something. And just keep in mind that these topics are based on ratios. Yes, I like how you have that. Ravina, that is a very nice formula there. I'm going to steal it. I'm going to write efficiency in words as words. Efficiency. So efficiency is, I'm just going to put output over input, but then if you look in the chat, for this particular question, Ravina's formula is actually a nicer version of this. So mine's more generic, and hers is more specific to the question. So anyway, either one's good. So we have the output, which is 2.6 watts, and the input, which is 9.6 watts. Notice that the numerator and the denominator have the same units. So those watts are going to cancel. That's good news, because if they don't cancel, you can't necessarily divide them out nicely. It's a bit of a headache. Can you give me that to the nearest percent? Anybody?
27.
Yeah, 27 is good, Anthony. Beautiful. Okay. Question 54 is kind of the same thing, but without the percent. But before we do 54, I want to do 55 first, and then we'll take a break, and I will write down the answer to the questions that I skipped during the break, okay? So 55, last question before our little break. The percent grade of a road. All right, here we go. I wonder if you ever seen this formula before? Have you ever seen rise over run? That looks familiar, doesn't it? What is it from? Where did you see it? Yeah, that's slope. Thank you. Percent grade is the same thing as slope. It's just the same thing. So slope is rise over run. So in this case, the rise is 75 meters, but the run, oh no. See the problem here? In the previous question, the top and the bottom had the same units. That's why I chose this one next. I'm chess with you. Strategy. Big problems. Okay, so what do we do, Victor? We have problems, we solve them, don't we? I need you to give me a solution. I don't want you to complain about it like I do. No idea. Okay, convert. Yeah, Mario, convert what? No, you got this, Victor. How many meters are in a kilometer? Do you know? There you go, man. All done. Have a nice day. See? 75 meters over 1,200 meters. Yay, they're the same now. The meters cancel. You nailed it. See that? Okay, what do we get? Give me a percent, please. 6 and change. I got 6 and change. I got 6.25. Awesome. Thank you, Ravina. Now, this question, I chose it because we are taking a break in less than a minute. I did choose this one on purpose because of the following. Who's ever seen this kind of sign on the highway? Yeah. I see them all the time when I visit my relatives in Greece, on the mountains, in the mountain roads. Yeah, math. It's just talking about the slope of the road. So when it says 8%, it means the slope of the road is 8%. Yeah, definitely it is. Like if you go north, when I go to like up north, northern Ontario stuff, yeah, that's all over the roads, especially in the Canadian Shield. So anyway, that's just saying that for every 1,000 meters of road, it rises 8%. 8% is 80 meters. So you can do a quick, yeah, it's everywhere. Yeah. I think I'm not really paying attention to where it is on the road as much. Okay. Let's take a break, everybody. It's 1:53. Take a break until 20. I'll give you a little bit extra. 2:05, okay? Break till 2:05. I will be in the chat here. No, I have my decaf. I have my decaf. Scroll up to 53. Can you see it on the side? Yeah, you have a quiz. Sorry. You can ask a homework question during the break. Absolutely, Mario. I don't know how you're going to share it with me. Is it from the textbook or is it somewhere else? Sorry, I'm just in the middle of answering an email at the same time from a student. Okay, so sorry, I'm out of the chat and I am back. So which question? Second one, 10, number 23. Okay. Where is 23? Oh. It's not even in the book. Oh, okay. Let me crack open the book here and take a look with you, okay? Because I don't see it in the book. So, I mean, sorry, I don't see it on the solution manual. No problem. I'll just do it over here. Yeah, 10 over 3. I'm with you on that. Sorry for the confusion. You know what the tiebreaker is? If you don't get the same answer as the book, photo math. Photo math. Who's used photo math? Yeah, or it's on Snapchat too, I think, right? Pretty sure it's on Snapchat. It calls it as well. So anyway, just saying. I'm going to scroll up to those questions that we didn't answer on the board together. So I'm going to just put it here. So I'm going to just, I am going to leave my computer for about 5 minutes, everybody. So I'll just post the 3 answers, then go away from the computer. Okay, we're back. Can you hear me? Cool, thank you. So we're going to work on some variation questions soon. But first, we can do a couple of more ratio questions. So take a look at question 56. These are the kind of questions you probably saw early in high school. Again, remember the first little while of this course is just reviewing all the stuff from high school up to calculus, but not including calculus, that you should know for this program. So in this case, it's a ratio question. We have the fuel economy for an airplane. That is, if it consumes 36 gallons, it'll fly 428 miles. And then it says, now if it has 52.5 gallons, assuming the same conditions, how far will it fly? So with these types of questions, it's nice to create or to just define what units will be here in the denominator. So I'm going to put here gallons per mile over miles. So I'm going to try to write down whatever formula I have here. I'm going to try to make sure that I have the gallons on top always and the miles on the bottom. So on the first situation, we have gallons is 36 and 428 miles. For the second situation, we have 52.5 gallons, but we don't know the miles. In the past, I put question marks for this kind of stuff, but now like percent questions, I'm going to put an X here as a variable. So how do you solve such an equation? What's the algebra we did last week on that? Yeah, thank you, Ravina. Cross multiply. So we do the 36 times the x. Thank you, Shazad. So 36 times x equals that stuff multiplied. So 428 by 52.5. And you can solve for x. I'm going to just state the final answer. 624. That's what I got as well. Very good. And there you go. 624 miles. Yes, Ahmad, there are definitely decimals there, but I'm going to round it to 3 significant digits. So whatever the rounding is, just make sure all of you remember how to round it for the how the question asks, because that'll be very picky. So question 57 is along the same lines. It's another ratio question. After this next question, we're going to move into the new topic, like the one that's probably new for everybody, or at least most people. So we're going to talk about now a comparison of slopes. So when I see a question involving the word slope and rise and run, and it's two different scenarios, I immediately want to set up a ratio, or a comparison of ratios. So rise to run, I'm going to have a fraction equals a fraction. So in the first case, the rise and the run are 3 and 6.3. The units are consistent, so I'm not worrying too much about writing the units. When I see a question where all the units are consistent, I tend not to write them in the actual answer because it's safe. I know it's not, I'm not being lazy, I just know it's safe. Like, I know that I don't have to worry about it. But if you remember the question earlier when we had kilometers and meters, I got very, very picky. I wrote the units everywhere because I was worried I might screw it up. So over here, what is the run? So we don't know the run when the rise is 4.2. Algebraically, this question is a carbon copy of the previous one. I haven't checked the answer, Syed, but 8.82 is good. Thank you very much. So 3x equals 6.3, whoops, 4.2. Awesome work. Awesome work. Now, you notice that I'm typing stuff and I'm copying and pasting and whatever, right? I don't expect you to answer a question like this fast. Okay, so if you do find that I'm going quick on my writing and maybe your hand is getting tired, the good news is the next 10 questions that we do approximately are really very little writing. So you're gonna have a chance to give your arm a break. So yeah, absolutely. Yeah, I just wrote 3 because when the answer says 3 significant figures here, I tend to not get as picky as how I write it, but you should write the extra piece there. So yeah. What prox? I don't know. Does it work out exactly? Okay, sorry, that's my bad. 8.82 it is. I think that's a typo on my answer key because I've typed up my answers prior to this, so that's a typo. I won't be able to fix this typo and get you the solutions in a timely manner. So I am going to post my solutions, and there will be an approximate symbol there. So sorry about that. Hopefully it flies under the radar and doesn't scare too many people. Thank you for that. I should have seen that. 42 is divisible by 3. Thank you. That's pretty sad. And so is 63. Oh well. Anyway, let's move on to the new topic. Now this topic is very interesting. So I'm going to scroll way up to the actual theory. And as I told you last week, I put all the theory in the beginning of the booklet. So it's kind of like a place where you can look and browse for the key formulas. So we're going to talk about a topic called, you're welcome. We're going to talk about a topic called variation. So we're going to look at the following idea: things varying directly and things varying inversely. And what does that mean? Well, the short answer is the following. I'll just say it in English. Just type it. I mean, I was going to put symbols. So when you get something like this is saying as x goes up, so does y. but it goes up in a very mathematical way. Whoops. And in the next situation, when we have varies inversely, as x goes up, y goes down. So it's kind of like a give and take there, okay? Can you think of situations in everyday life where the more you do of something for an input, that the output is also more? One example is when you work hours at a job. So let's say that you're working, you get paid whatever, 25 an hour or whatever it is. Yes, Victor, that's a good one. I find for me the running one would be the second case. The more I run, the less stamina I have. But yeah, so whenever you something like the more you do, the more you get, that's the first case, which is direct variation. And then inverse would be something like the more you do, the less you get. So there's different things that are like exercising, right? You know that? True. There you go. The faster, oh, how about this one? The faster you run, the less time it takes to get to your destination. So you can have things like that. And these ones here are very plain. Notice that the x here has a power of 1. Now, it doesn't have to be x. It could be x squared. It could be square root of x. So look out for those things. Ultimately, what you're going to do for the next series of examples is take the words that I give you based on some experimental or theoretical observation, and you're going to turn it into a formula. So here comes the first one. Revenue varies directly with number of days worked. I don't know how you got that symbol in there, Shazad, but that's amazing. Thank you. So R, you're a champ. So that's the actual variation here, okay? What it's saying is that R varies directly with X. This thing here, this symbol, is called proportional. So we can say it's called proportional. Notice this symbol, I have a shortcut. I write prop 2 because it's proportional to. So even the symbol has a good name. That's how you find the symbol if you're looking for it, other than Shazad's Google search, which is wicked. Okay, now this here is not an equation. This is a statement of a relationship about how the input behaves and how the output responds to the input. If you want to turn it into a concrete equation with an equal sign, so you can do algebra and solve for stuff, then you put the following. You replace the symbol here, which is just telling you how things behave relative to each other, with an equal sign and a constant. So K there is a constant. K is a number that you can determine for the given application. So we're going to go through 2 examples before you do your quiz. And your quiz is not on this stuff. Remember, your next week's quiz is on this stuff. So we're going to go through 2 examples where you go from the relationship to actually creating an equation and using it. So this thing here, this letter K, why do I use the letter K? Because I feel like it. You can put whatever letter you like there, provided it's not been used already. So if you want to put here, if you like the letter C or whatever, that's fine. But I'm going to use the letter K. So let me be a baby and do what I want to do, okay? So there we go. I am going to do whatever I feel like. Taking a stand. Okay, can you set up a proportionality statement for this one? Force varies directly with the surface area. Is this correct? Any comments on that? What's the comment, though? Like, what do you think? Is it right? Okay, so the word is directly, but what about this word here? I am definitely not trying to play mind games, but I am telling you that it's squared. Yeah. Thank you, Gabriel. Gabriel with the win, for the win. There you go. You got to put an A squared there because just make sure you read through the words here for those keywords, okay? Like directly and square. Then you can turn this into an equation by replacing the proportional symbol with K. And that is it. But your final answer is this. I just want to emphasize that all you need to do is write down the thing that's big and bold here. Okay, so I said to you, these questions won't take a lot of writing, but we're going to do probably another, I think it's 8 of them. So let's get going. Let's get on our motor here and do some work. Okay, your turn. You got 30 seconds to do 60. It's very quick. Try to underline the words. Oh, surface area of a square. Okay, I gotcha. I see. So, proportional square. Anybody who's taken physics will recognize this formula. Yes, that's right. That letter, the letter thing you're saying, Victor, is called proportional to. Okay? Oh, not to. Sorry, to. Duh. Sorry, my bad. Hang on. There you go. Okay. It's what's funny is that when I'm gonna post these lessons on this lesson on YouTube eventually, once I edit it for any like empty space for the video, they don't see the chat because I don't post the chat there. So why is the K there? Okay, so this symbol here is just saying that D and T squared have a relationship between each other in terms of how they grow or decay. The K there is to turn it into a constant. It's an equation. Thank you, Ali Akbar. Because you want to turn this into an equation. This here is just describing how they compete with each other. The second one tells you a concrete formula. So yes, K is just a constant. It's a constant to turn it into an equation. Yes, this is correct, Victor. Eventually, when you get an application question, we will do 2 questions today, Victor. 2 application questions where we turn K into a number based on some information that we're given, and then we finally have a formula that we can use and do stuff with. So you're going to see that process, I promise you, within the next 30 minutes. Inversely related, Ravina, is you're on the next one, right? No, directly. Okay. So inversely just means, yeah, 1 over. And we're going to get to that in 2 examples. So this one more, and then we'll move on, okay? You're welcome. All right. Energy is proportional to speed of light squared. So remember, you can just underline the keywords as you need them. So proportional light squared. Okay. I'm going to steal Ravina's thing there, because that's correct. But I'm going to change the letter K. What letter am I going to use? What letter can I use? That's right. That's an M. So in this question, Unfortunately, you're not allowed to use whatever letter you like. You have to use the constant M. So no K for you. We're going to use the letter M. Okay? Whoops. Does that equation look familiar? Yeah, Einstein, right? E equals mc squared. Yeah. If you're curious, this equation, when did you do it? Did you do it in physics class? Oh yeah, I think we did. That's right. That's right. So anyway, the short on this equation, we're not studying modern physics here, contemporary physics, but it's just says that if you have so much mass and you're able to convert it to energy, this is how much energy it would be. And because the speed of light c is really big, and when you square it, it's really, really big, then a very little mass can create an enormous amount of energy. Kind of the premise on how we have energy from nuclear reactors, but also for other things like propulsion systems or futuristic propulsion systems. Okay, new word here. What word is interesting in this case? What's the word that's different here? Yes, thank you. So earlier I showed you it inversely means 1 over. So we have here P, and it's going to be 1 over V. That's how you do an inverse relationship. And then you can introduce a K. But you notice that there's brackets here? I don't like that. So what I do is this. I just put the K on top. I just do this instead. So this is my answer here. Whoops. All right, next question. Intensity varies. Is that right? What's wrong with it, Victor? Yuppers. Good job. No. You said Victor. You said no. So that means you're right. When I asked you, is it wrong? You're like, yeah, that's good. Okay. So that's a brief little run through. We got a few more here, so it's just going to keep on going now. We got 4 more to go. So I'm going to go a little quicker on them now because, as I told you, they're very short questions. So I'm just going to state them a little bit faster here. Time, this is one that I mentioned to you. The faster you go, the less time it takes to get there. So that's this one here. I'm not putting the proportional today. I'm sorry for this one here. There's a couple more to see. So you're looking for those keywords, okay? Okay. What's the answer to this one? Try to type it in the chat box if it's easy for you to type. I put t twice, didn't I? My bad. Sorry. I'll blame the coffee on that one. Anybody want to take a guess at the next one in the chat box? Ravina, you are correct. Yes. T is inversely proportional to square root of roof area. Excellent work, everybody. That's good work. So, I think that we have one more to go, and then I can show you how to do a couple of word problems. Okay, I'm going to join in on this one. There's a mathematical pattern. You know you're in good hands with the teachers asking the student for the answer, right? Just kidding. No. Okay. Chat's out of control. I got to rein in the chat here. Chat is full chaos now. This one is a different question. It's a joint question. So what do you notice in this question? The difference here is that, as you might realize eventually, not all things in formulas have one input. In this case, the stiffness of a beam is going to jointly depend on two things. One, the width of the beam, and two, the depth of the beam, but specifically the cube of the depth of the beam. So this is called a joint variation, and you can combine them into one. Yeah, that's the right answer. Nice job. So what you can do now is make a joint variation. That'd be S prop to proportional to WD cubed. And then state your final answer, S equals KWD cubed. So look, we just blazed through, well, 10 questions or so, maybe a bit more, where you're creating a formula based on a statement. Now, if you're wondering, where do these statements come from? How does someone know the stiffness of a beam varies this way with the depth and this way with the width or whatever? Or the area of a roof with the tornado pressure? You don't have to figure those things out for this course at least. But those things are based on experiment. So people conduct experiments, they take observations, they record observations, they plot the information, and then from that plot or plots, they are able to model it with a formula or a variation relationship that they can create a formula from. And then what they do is they apply the formula to real life again and again. And as long as it's consistent, then the formula is believed to be correct. That is pretty much the basis of how science is conducted, at least for the past many thousands of years, since ancient times, ancient Egypt, or even older, okay? So anyway, enough of us just telling you, make a formula based on some observed or statement or whatever. I want to apply a formula and do stuff with it. So we have about 20 minutes or so before your quiz, and I'm going to do that with two examples. So if you go back to the actual lesson plan, you'll see that I've made a little algorithm here. So we're going to apply this strategy to some questions. Okay, so take a look at question 68. The first sentence is going to help you do step 1, which is to create the formula. So what we did in the past 10 or so questions was make the formula. The second step, which addresses many students' comments, is you're going to determine the constant k. You're going to actually get a value for k for this particular situation. Then step 3, which is very short, is you're just going to update the formula because now you know what k is. And then you're going to do step 4, which is you're going to use your new formula and take it for a test drive. You're going to apply it somewhere. So let's go through that process in a very patient way. Step 1. Step 1 is that the volume is directly proportional. The volume of carbon dioxide that is exhausted from a room is directly proportional to the initial volume, which is V sub 0 or V naught. That's step 1. Step 1 you've been doing 15 times already. So, or whatever it was, 12 times I think. Now we're going to do step 2. So step 2 is to find K. So for step 2, we know when over here, when V naught, I'm with you in a second there, Ravina. You can do that as well, but I'm going to leave it like this for a second. You'll see what I'm doing. I'm just trying to be very uniform with all the questions. When V naught is 75, sorry, when V naught is 160, there, that's what I was trying to write. Sorry, I was having issues with my keyboard. So with that information, either you can rearrange the formula as was done in the chat, or you can just plug in these numbers into this formula and solve it with your algebra. It's the same thing. I don't want to solve for k explicitly because I'm not mean to k. K is not that special to me. So I'm being very mean to k. I'm going to file a apology letter to k after. Write a little letter to say, sorry, k. We value the rights of k. Every poor K, I know every letter in the alphabet, right? It's just I'd always pick on K, and I always pick on Bob. For a lot of examples I write on the board. Obviously, we're not in the classroom. I always use Bob, but I make sure nobody in the class is named Bob or Robert because I don't want to like get in trouble because that'd be really funny or sad at the same time. Anybody got a decimal for K? Please confirm that you got this number. Okay, good. Now step 3 is easy. Step 3, you just update the equation. And then step 4 is you apply it. So here's the last step. How much carbon dioxide is removed when the volume is 130? So you put 130 here, and that's it. Three significant figures. No, nearest cubic foot, please. So 61. Okay. I just want to make sure I'm seeing in the chat lots of people typing, and I'm seeing a variety of names, which is excellent, and a variety of people. But I'm just going to ask you at this point, how are you guys feeling about this material? Can I get some feedback? Can we go over the gist of that equation again? Which equation? Which equation, Victor? Okay. I'm glad the feedback is good. Pulling the numbers. What did you do to get that? So what I did here was I took okay, so Joseph, better? Okay, so the question here is why is not time included in the equation? Because it's assumed that for all of the measurements taken, this is the amount of carbon dioxide that is removed in an hour. So it's, you're welcome. It's about the 1 hour is consistent for the entire question. Okay. So if it wasn't 1 hour for both situations, this question would be a really, really tough question. So the 1 hour, as far as you're concerned, is just the fact that they're both the same amount of time before and after. Like in the reference, it's 1 hour, and the after is 1 hour. All that matters is that they're the same. You're welcome. So it's about just consistency for that. In terms of the numbers, I guess the main thing is the key step here is step 1, Victor. Back to your comment. As long as you understand that the first statement is presenting you with a variation, and you'll see that because you see words like varies directly, literally in the statement, you should be able, thank you. And this is not for you anymore, this is just for the class. You seem to be back on track. So this is the key. Once you make this statement out, then try to use the information that's given to create yourself a nice formula. So really step 3 is the big step. Once you have this, you've unlocked the question. Gotcha. So step 2, we're gonna practice step 2 on the next question. And the next question is our last question before your quiz. So there's questions 69 and 70. I'm going to take 69 with you, and then 70 I'm going to post the answer on Blackboard. And 70 is just after the quiz we have more class. What I do after the quiz, because it's like not much time after that, depending on how people are doing, I'm going to stick around in the chat and answer individual questions. So that's what I try to do with the 3rd hour during the quiz. Whoever finishes early, they can come back to the chat and they can ask me questions about homework. They can ask me questions about the course, whatever. So that's kind of like an open forum for people to ask questions. So it's optional in terms of your attendance after the quiz, but I will stick around for extra questions. Okay, so let's go to question 69 and we'll wrap up our last example before your quiz. And then after we do this example, I'll help you out with the quiz and setting up on MyLab and whatever else you might need. Small stuff. So, the productivity of a factory is directly proportional. So let's get out our highlighter or something here. Is directly proportional, whoops, to the square root of the number of employees. So that's kind of like the hint on how to build the formula. There's a square root in there. In the question, there's a square root. Did you see the square root? Okay, all good. So literally, it's all good. So I don't know if you have it printed on paper, if you're looking at the screen. This is the kind of question you got to get your hands dirty with the highlighter and just kind of chisel out all the keywords. I remember doing that back in the day when I was writing tests. I'd have to chisel out all those words Because as a student, I wasn't the fastest reader back in the day. Yeah, many years ago. Many years ago. Okay, so let's get step 2. What's step 2? Find K. So we know that when n equals 16, P equals 500. So use that information to find K. Can you do that? So plug in 16 and 500 and solve for K here. So 500 equals K times the square root of 16. That is correct, Shazad. I chose nice numbers here, so at least this one here you can't get too mad at me. Let me see here. I think it's 559. I'm going from memory on that one. Yeah, whatever Peter says. I'm with Peter. Okay, we have a formula. Congratulations. That is your quarterback. That's the one making all the plays, okay? Now we have this. We can do whatever the heck you want. You want to apply it to find out how many employees you need. You want to find out how many parts you're going to make. That's what you do for the last step. So the last step is right here. Find P when n equals 20. So you hired 4 extra people. Let's see how many extra parts you're going to make. Can't type. Having issues here. And I got 559 as well. And that's that. So what'd you think? How was today's lesson? Was it punishing? Okay. Well, good to hear. I'm seeing a lot of comments. We got a whoa. we got neutrals. I got some neutrals. Not bad, Brian. Getting better. Okay. So we're gonna we're gonna get into the quiz now.